I've already created I want to create a drawing. The following is a presentation of assembly modeling inside of Edge ST3. On the screen before you, you can see the Iron Eagle or the Dixie Chopper lawnmower. And our challenge today is to create a new lawnmower deck. I've already started the process and defined the part. So I'm going to right click that from the Pathfinder and do a file open. Here you can see a lawnmower deck that's partially created, at least the sheet metal components have been brought in. I'm going to use my configurations and shut off the display so that we can get started to the design intent or the concepts of this lawnmower deck. And essentially what I care about on a lawnmower deck is my width of cut and the diameters of my mower blades, as well as the relationships of these mower blades with each other. And here I've created just a simple 2D sketch to contain that intelligence. The next thing that I care about is the drive belt. So I've created a second sketch where I've defined a drive belt that runs maintaining concentricity to the lawnmower blades. By using this sketch, let's jump to another configuration, which is assemble. You can see that I've already started to assemble some subassemblies onto this sketch. So let's add a few more so you get an idea of what that process looks like. So this is the subassembly of a lawnmower blade that I want to use, and I'll just drag and drop that in. And when I create a subassembly and I've added relationships, and I can save those or capture those relationships. So therefore I can just simply select where I want these to apply to. So I'm going to be axially aligned to the center part of the belt and to the top of this, which is already mated through the center. I would set this up because this is a library component that I'm using over and over again on different blades. The next part that I want to add is the part number 37. And again, I've already captured relationships, so I want that cylindrical edge to be axially aligned here and axially aligned here. And then the top of this is going to be the same as the top of here. One of the benefits of applying these types of adding my assembly constraints to the sketch is that, especially in this case, this was set up to be 1222 millimeter width of cut, and I'd like this to be 1122 millimeter instead. So I simply select the dimension and make a change. The other thing that's different is that these blades that I'm putting in are not 500 millimeter across, they're only 430. So I'm going to change this dimension to 430 as well. And you notice that this sketch allows me, since it's capturing the intelligent or the intent of how this blade is supposed to perform, when I change the dimensions, it rearranges all of my assembly components for me. When I'm finished, I'm going to jump back out, and you see that the belt path still keeps its concentricity across these, which is just simple sketch modeling capabilities. But what I do need to worry about is that although I've got the width of the blade diameters and I've got the width of cut defined, what I do need to make sure is that I have a belt that I can purchase the correct length of. So what I've done is when I created the sketch for the belt, I took the perimeter and I associated it to a parameter called belt length. And that parameter is currently at 2618, and I want it to be 2650 millimeter. And I'm going to achieve this length by changing the tensioner angle. And the tensioner angle is a dimension that drives the angle of this line, which controls the center of this location. And by adjusting that, I've now brought this to my 2650 millimeters. So that easily, by having just 2D intelligence, I've driven my entire three-dimensional model. The next step that I would like to do is I want to create an actual belt here. And I've created a part already to save that step. And I've already associatively copied in my my profile. So let's double click this to edit that in place. And you can see that I've got a path and I've got a profile. So I can simply come to solids, do add sweep, and I'm going to sweep on this path, this profile. And that easily I've added a belt. So let's close and return. And let's travel to the top of the Pathfinder, and I do not need to see these sketches anymore because we've already committed to our new sizes, and I'm going to do a show all to see the complete assembly. Now, since I've made changes to the belt path and the locations, I'm going to just take a quick look around at my model, and it would appear that there may be a interference between this riser, this bushing, and the belt. So let's do a check interference. Now I could do a check interference targeted by just picking what components or set of components I want to check against another set of components, or I can do an interference by checking the entire thing. And here I pretty much know what I'm looking for, so that's the area that I would like to make a change. Now, how would I go about making this change? Especially if this was a three-dimensional parametric system. I would need to either drive the location of this hole or drive the length of these different components, or vice versa. But since this is a synchronous model, what I can do is I'm going to set my priority to select faces, and I want to adjust that. I'll set the steering wheel against this edge, which gives me a direction of like a 3D stretch, if you will. And when I start this direction, oops, I'm telling it to move the entire components, so I need to tell it to only to go ahead and stretch these within the subassemblies. And by running this on stretch, I can simply stretch this by 30 millimeters. So what I'm going to do is take a quick snapshot because I want to get back to this view, but I do want to show you something. And if I go and wait for my quick pick to come up, and let's grab this entire assembly here, and we're shut off its visibility. And if I zoom down here, you can see that that stretch operation not only modified components into a subassembly, it also grabbed these features and moved those features in my clearance holes as well. So now my assembly changes are completed. They're the correct size that I'm looking for, and I've corrected my my interferences. So let's do a save. So now I'm going to create a drawing. So I'll go to Create Drawing, and I won't use the drawing wizard, and let's go into Quick Sheets, where I've already created a quick sheet for my mower decks. By using a quick sheet, this will automate the process of creating all of the different views that are important for this product. As this product keeps getting variations and it gets redocumented. When they run this, you can see that my predefined views are automatically generated, including my detail views, my balloons, my bill of material. The drawing views that get generated are fully associative. So let's do a quick dimension from the inside of here across to here, which is essentially my actual width of cut. So my 1125. And let's put on just a quick dimension here, and I don't want that to be a radius, I want this to be a diameter. And we can drop that detail into here. On this particular quick sheet, I've created a second sheet, and the second sheet has exploded views. And the point to this is not to show that this exploded view is not associative, it's preset. However, what I wanted to emphasize is that the tools are all available in the 3D assembly modeling to create exploded views and rendered views, and to capture all of the different documentation required from your assembly process. Thank you, and that concludes our presentation for Solid Edge assembly modeling.